Okay, for what we have in section R.8 in this particular simulation, okay, we have to get the 10% discount, a shopper must spend more than $100. And it says to use D to represent the spending in dollars of a shopper who gets the discount. Okay, so when you're looking at more than, and we have D on the left-hand side, okay, so we have that D is greater than 100. And then we have for the next portion, we have the cargo of the truck weighs no more than 2,500 pounds. Okay, so W, if it represents the weight of the cargo, it's not going to be greater than 2,500. Now, it can be up to 2,500, and it could also be less than 2,500. So we can say that for this statement to be true, if we translate in terms of inequalities, we will have that W is less than or equal to 2,500. And so we have, upon checking the result, and the statements are correct. Now, for what we have in the next statement, okay, we have that -2 is less than x, and 4 is greater than or equal to x. Now, in terms of writing as an inequality, okay, so we have -2 is less than x, and we have that 4 is greater than or equal to x. And for what we have here, okay, we can make this into a compound inequality because we have -2 is less than x and 4 is greater than or equal to x. Now, the second inequality statement, if I have x on the left-hand side, I have that x is less than or equal to 4. So 4 is greater than or equal to x. It's the same logically as x is less than or equal to 4. And if I were to tie these two statements in together as a single compound inequality, I have that -2 is less than x, which in turn is less than or equal to 4. So in looking at writing what we have here, and it says to use x only once in your inequality. So we have -2 is less than x, which in turn is less than or equal to 4, and checking the result, and that is correct. For what we have in the next item, it says to write a compound inequality for the graph shown below using x for your variable. Okay, so we have, with this particular line segment, we have a graph on 3, and we have an open circle on 7, and we have everything else in between what we have 3 and 7. And so for what we have in this particular case, right, so for a compound inequality, now 3 is included, and everything else is going to be greater than or equal to, so we can say we have 3 is less than or equal to x, and with the open circle on 7, that means 7 is not included, and so with 7 left out, we have 3 is less than or equal to x, which in turn is less than 7, and checking the result, and that is correct. Okay, for the inequality that we must solve, and we have the variable x, and here we have 36 minus 4x is less than 16. And to looking at solving for x, so you have 36 minus 4x is less than 16. And if I look at isolating the variable term, so I can take 16 from 16, I have taking away 36, so eliminating 36 from both sides, I have that -4x is less than 16 minus 36, which will be a -20. And to isolate x, so we have -4x over -4, and to the right I have -20 over -4. And if you multiply or divide by a negative, the direction of the inequality is going to change, and that's because of, in this case, division by -4. And so we have in this outcome, we're going to have the x is greater than 5. And testing out what we have here. And the result is correct. Okay, for this particular portion, now we have 2w plus 1 is less than or equal to negative 3, or 4w minus 3 is less than 21. Now we have with the bus term or, you're looking at combining the solutions into a set. In other words, you're combining the solutions from the inequalities. And for what we have for the first inequality, so you have 2w plus 1 is less than or equal to negative 3. And in the case of isolating the w term, so if I take 1 away from both sides, so I'm going to have 2w is less than or equal to negative 4. And we have with division by 2, we will have that w is less than or equal to negative 2. In the case of what we have with 4w minus 3 is less than 21. So if I add 3 to both sides, and we have that 4w is less than 24. And we have with division by 4. So we're going to have that w is less than 6. Okay, so you have w is less than or equal to negative 2, or w is, all right, so you have that w is less than or equal to negative 2, or w is less than 6. Okay, and I'll just give you a little bit of visual here. Okay, so you have w is less than or equal to negative 2. So you would have a close point on negative 2 with the ray going out to the left. You have where w is less than 6. For w is less than 6. Okay, so you have an open circle, meaning that 6 is not included. Now, in the case of what we have for w is less than or equal to negative 2, or w is less than 6, we're looking at combining all the values between these inequality solutions. So in this particular case, it'll be the second graph. And this is going to be your result. Now your interval solution in this case would be, you have from negative infinity, your lower limit, up to and not including 6. So you have open parentheses throughout. Okay, and let me just mention this just a little further. All right. Again, you have the word or, so you have combining solutions. Now, if I had the statement to be w is less than or equal to negative 2, and that w is less than 6, you're limited to only the values that would be common to both sets, and your solution in this case would have been limited to. In other words, what belongs to both sets, okay, you would have just those values less than or equal to negative 2. And this would be your graphical solution. And as an interval, you have going from negative infinity approaching and including negative 2, where that would be in the bracket. Okay, but since we're looking at the linking word to be or, Okay, this is what we have in the result. And so checking out, and we have in the mix. So again, we have going from negative infinity, approaching and not including 6. And for the result, that is correct. Okay, for what we have in this item, it says to write an absolute value inequality for the graph below, and it says to use x for your variable. Okay, so for what we have in the spread, we have a line segment between negative and positive 2, but not including negative or positive 2. And if I were to write this as just an inequality, I would have that negative 2 is less than x is less than 2. And if I were to express this as an inequality, notice we have with the compound inequality, this goes back to our statement that if we have that the absolute value of x is less than k, then we have that, in this case, you have negative k is less than x is less than k. And if I were to write the converse of this, if negative k is less than x is less than k, then you have that the absolute value of x is less than k. All right. So just what we have on a parallel. So you have negative 2 is less than x is less than 2. So for your absolute value inequality, you have that the absolute value of x is less than 2. Okay. So for what we have in this statement, so we have that the absolute value of x is less than 2. And we have with checking the result, and that is correct. Okay, for what we have in the next item, it says to graph the solution to the inequality on the number line. Okay. Now for the inequality itself, we have the absolute value of w minus 2 is greater than or equal to 7. And we have with our rule of thumb. Okay, so if we have that the absolute value of x is greater than or equal to k, then you would have that x is less than or equal to negative k, or that the value of x is greater than or equal to k. Now we have x represented by w minus 2. So you have, in taking the extremes, so you have w minus 2 is less than or equal to negative 7, or we have that w minus 2 is greater than or equal to 7. And solving each of the inequalities, so we have on the one hand, we have that w is less than or equal to, and we have negative 7 plus 2 is negative 5. And it could be that w minus 2 is greater than or equal to 7. And this translates out to w is greater than or equal to 9. And just for what you have envisioning, okay, so you have negative 5 and positive 9. And graphing the solutions, you would have, thanks to the equal signs and the inequalities, you would have solid points on both negative 5 and 9. Now for w is greater than or equal to 9, you have a ray going to the right. And thanks to the less than sign from negative 5, you're going to have a ray that will go out to the left. And so just carrying over what we have here in graphing, in case you have a solid point on negative 5 and a solid point on 9. And from 9 you have a ray going out to the right, and from negative 5 you have a ray going to the left. And checking the result, and that is correct. Now for this next item, we have graphed the solution to the inequality on the number line. Okay, and here we have the absolute value of 3u minus 12 is said to be greater than 9. And we have for the setup, okay, now there's a rule that states that if the absolute value of x is greater than k, then we will have at the one end, we have that x is less than negative k, or that x is greater than k. And having x to be represented by 3u minus 12, we're going to have, upon removing the absolute value notation, we will have at the lower end, we have 3u minus 12 is less than negative 9. And we have at the upper end, we have 3u minus 12 is greater than 9. And if I isolate the u term in each inequality, okay, so adding 12 to both sides. Now, for 3u minus 12 is less than negative 9, we have that 3u is less than 3. And if we go ahead and divide out, so we will have that u is less than 1. And for 3u minus 12 is greater than 9 upon adding 12 to both sides. So we have that 3u is greater than 21. And with division by 3, okay, we have that u is greater than 7. So for what we would have, at least in graphing terms, notice we do not have the equal sign included. So you have u is less than 1. So on 1, I would have an open circle less than 1. So we have a ray that is going to the left. And again, we have u is greater than 7. 7 is not included, so we have an open circle greater than signals that we have a ray going to the right. And so looking at what we have here, so you have, again, an open circle on 1 and on 7. And taking what we have, so you have a ray to the right and a ray to the left. And the result is correct. Now we have, in this remaining problem, we have a multi-step absolute value inequality. And here we have 4 times the absolute value of u minus 2, followed by the subtraction of 3, is less than or equal to 25. And it says that if all real numbers are solutions, click on all reals. If there is no solution, click on no solution. So we have, in the case of this particular multi-step absolute value inequality, so we have 4 times the absolute value of u minus 2 minus 3 is less than or equal to 25. And again, you're not going to distribute 4 over the absolute value of u minus 2 because we do not treat absolute value notation as we would parentheses or brackets. Okay, so isolating the absolute value of u minus 2, we have in the initial phase, okay, we add 3 to both sides, and we have 4 times the absolute value of u minus 2 is less than or equal to 28. And we have with division by 4, okay, so we have that absolute value of u minus 2 is less than or equal to 7. And there's a rule again that states if the absolute value of x is less than or equal to k, then you're going to have a compound inequality that results where we have that negative k is less than or equal to x, which in turn is less than or equal to k. So for what we have for u minus 2, once we take out the absolute value notation and we have k represented by 7 and writing as a compound inequality, so we have negative 7 is less than or equal to what's going to be u minus 2, which in turn will be less than or equal to 7. And getting the variable u by itself, so we add 2 throughout. in the middle, and also the opposite ends of the compound inequality. So we have that -5 is going to be less than or equal to u, and that in turn is going to be less than or equal to 9. And so carrying over to what we have here, we have -5. Again, we have less than or equal to u, and u in turn is less than or equal to 9. And checking the result, and that is correct.